Hi guys, this is Miss Gold. Today's lesson is Module 2, Lesson 13, Writing, Evaluating, and Finding Equivalent Expressions with Rational Numbers. Your outcomes for today's lesson are students create equivalent forms of expressions in order to see structure, reveal characteristics, and make connections to context. Students compare equivalent forms of expressions and recognize that there are multiple ways to represent the context of a word problem. And finally, students write and evaluate expressions to represent real-world scenarios. In the first example, what I'd like us to do is to get some practice with two simplifying procedures. One is called combining like terms, which you actually were introduced to in lesson 11, and also the distributive property. So we've seen the distributive property before, but we may not have seen it with x's. So what I want to do here is group the equivalent expressions together. So if I want to find equivalent expressions, what I probably want to do is look for the most complicated ones and then use distributing or combining like terms to simplify them and see if they match any of the other problems. So the first thing I look at here is 12 minus 4x. Now the big thing that I notice here is I cannot combine the number 12 with the negative 4x's. Those are not like terms. You can't combine a constant with a variable. So that is as simplified as it can be. So I'm going to skip that one for now. Maybe it will be the simplified expression of one of our more complicated expressions. When I look at our second problem here, I know that I have x's here and x's here, so we can combine like terms. So let's simplify 8x plus 4 minus 12x. So if I'm going to combine like terms, I take 8x's and I'm going to subtract 12x's from that. So 8 minus 12 is going to leave us with negative 4. So here we have negative 4x. I can't do anything with this positive 4, so I'm just going to put it on the end. So let's match up two of our equivalent expressions. So this expression is equivalent to negative 4x plus 4, which is right here. Okay, let's take our next expression. We can simplify this expression by using the distributive property. So I'm going to do 8 times 1/2 x minus 2, and we are distributing the 8 to both of the terms inside the parentheses using the distributive property, which is multiplication. So we have 8 times 1/2, so what you're really thinking is half of 8 is 4, and there's an x on that. And then 8 times 2 is 16, so we have minus 16. Okay, so that means we can match up this problem with 4x minus 16, which is here. The next problem I can simplify is 12 minus 6x plus 2x, and what I see here is I can combine negative 6x and positive 2x, so we're going to combine like terms. So we have 12 minus 6x plus 2x. Here, negative 6 plus 2 leaves us with negative 4x, and I can't combine anything with the 12, so it just remains a 12. So that is equivalent to negative 4x plus 12. So as I look through our list, I don't see a negative 4x plus 12, but what I do see is 12 minus 4x. So let's go back here, and we can switch these two. It's addition, so we can do commutative property. And so if I switch the two, it'd be 12, and we could write plus a negative 4x, but it would be more logical here to write minus 4x. And so now we have two equivalent problems. Looking through our list here, we have x minus 2 plus 2x minus 4. And in this, I see I could combine some x's, and I could combine some constants. So let's go through and simplify this problem. So by combining like terms, we have 1x here, so if it helps, draw that 1. And plus 2x here, so 1x plus 2x is 3x. And then we have negative 2 and a negative 4 combined to become a negative 6. So looking through our list here, we can say this expression is equivalent to this expression, 3x minus 6. Looking at the next expression, 4x minus 12 cannot be simplified. I can't combine the 4x and the 12 because they are not like terms. But if I look at the next problem, 4x minus 4, I can distribute in that problem. So over here, let's distribute 4 times x minus 4. So if I multiply the 4 to the x, I get 4x. And if I multiply the 4 to the negative 4, I get negative 16. And you can see that that's actually equivalent to one that we've already found. So let's label that with the same color of 4x minus 16. The next problem I have is also distributive property. We have 3 times the result of subtracting x and 2. So let's distribute here. So I multiply 3 times x and I get 3x, and I multiply 3 times negative 2 and I get negative 6. And you'll notice that that is just like the problem above it, and so we already have that color done as well in green. The next problem I have is quite complicated, so let's go through and simplify this problem. So in simplifying this, I want to make sure that I'm always following PEMDAS. Going through PEMDAS, I know that multiplication has to be done before subtraction. So I have to make sure that I'm going to multiply these two and multiply these two before I subtract. So let's go through and do that. 1/10 times 40 will give us 4. So when I multiply these two, we have 1/10 times 40 gives us 4, and they have an x. And then we have minus half of 24 is 12, and so that matches one of our other equivalent expressions, 4x minus 12. On our next problem, we have 2x plus 2 times x minus 6. Now again, we have to learn to follow the order of operations, so we need to multiply before we add. And notice you wouldn't be able to add these anyway because they're not like terms. But we have to do multiplication first, and that here is the distributive property. We're multiplying a 2 to x and a 2 to 6. That gives us 2 times x is 2x, and 2 times negative 6 is negative 12. And then I still have some like terms to combine, so we have 2x plus 2x gives us 4x minus 12, so that actually matches our previous question. My next problem is 1 times x plus 2 plus 2 times x minus 2. And again, I have to follow PEMDAS, so I have to do multiplication first. 1 times x gives us x. 1 times 2 gives us 2. Then we have a positive 2 multiplied to x is 2x. And a positive 2 times a negative 2 is a negative 4. And then I still have some like terms I can combine. So x plus 2x is going to give us 3x. And 2 minus 4 is negative 2. So that gives us 3x minus 2. And notice as I look through, that doesn't match any of our problems. So maybe we'll come across a problem that simplifies to become that, and maybe we won't. Maybe it just doesn't match up to any of our other expressions. The next one I have is 4 times 3 minus x. Here I have the distributive property, so I'm multiplying 4 times 3 to give me 12. And 4 times negative x is a negative 4x. And that does match a problem we have already done. And finally, we have 4 times 2x plus 1 minus 12x. So the first thing I have to do again, PEMDAS. So the first thing I come across is multiplication. We are multiplying 4 times 2x. That gives me 8x. And 4 times 1 gives me 4. Then we have a minus 12x on the end, so I can combine like terms. 8x minus 12x is a negative 4x plus 4, and that matches a problem that we did towards the beginning, which is our yellow. So notice none of our equivalent expressions were equivalent to this problem here. This one was on its own. It wasn't equivalent to any of the other problems. One of the biggest things that we emphasized in example 1 was the distributive property and combining like terms, making sure that you're always following the order of operations. Multiplication always comes before addition, which is what combining like terms is. And the multiplication you will see is represented through distributive property. Okay, example 2 is going to start to introduce us to percentages. So the first thing we need to know about percents is that we never work with this form of a percentage. We're actually going to turn it into a decimal form. And how we do that is basically by moving the decimal over twice, because a percent is always out of 100. So if you picture dividing by 100, that result causes the decimal to move over twice. So here, if my discount amount is 20% off, it means I first need to know what is 20% of the original price. So in this case, my original price is 100. So I need to multiply 100 times the decimal version of 20%. So if I move this over twice, we get 0.20. So 0.2 is the same thing. When I multiply 100 times 0.2, this is going to cause, by multiplying by 100, this is going to cause our decimal to move over twice, and that gives me the number 20. Now keep in mind, that just tells us the amount that it's being discounted. So $100 is discounted $20. It's not discounted to $20. So what we need to find is what's the result when $20 is taken off the price, and taken off is basically subtraction. So I'm going to do 100 minus $20, and that gives us a final price of $80. Now I want you to look above here and notice it says new price, pay 80%. One of the things that can help you to reduce the number of steps you can do is to realize that whenever you are having a discount amount, it means that the store is paying that amount, and so you have to pay the rest. So if you think about it, you have to pay for what's left over. So if the cost is 100%, but they're going to pay for 20%, you therefore have to pay for 80% of the item. So if I look at it this way, what I realize is that if the store is going to pay for 20%, I have to therefore pay for 80% of the item. And so that reduces the amount of steps that I actually have to do if I can think of it this way, because it means I just have to find 80% of the cost of the item. So let's interpret that. 80% would be written as a decimal, so I move the decimal over twice, and I get 0.80 or 0.8, same thing. So I'm finding 80% of the item. We know that in math, of means to multiply, and the item cost was $100. So here, we are going to multiply 80 times 100. That causes the decimal to move over twice, and I also get $80. So notice here, you can do it in 2 steps like we did here, or you can think logically about it and do it in 1 step over here. Okay, let's do the same thing for 50. So I have the cost of the item, $50. We're multiplying that by 20%, which is 0.2. So how I can do this in my head is multiply 50 times 2, which is 100. But then there was a single decimal in the question, so I have to put a single decimal place in the answer. And so that gives us an answer of 10. Again, the new price, what we would do is, this is a $10 discount off of the $50. So we would take $50 and subtract $10, leaving us having to pay $40. Now again, if you can think logically about this, remember, we're only paying for 80% of the item because the store is going to pay for 20%. So we have 80% is 0.8%, of, meaning multiply the cost of the item 50. 8 times 5 is 40, and then we have another 0 here. It had a single decimal place, so I'm going to move my decimal over 1, and so the final cost of the item is $40. And notice we got the same thing, we just did it in 2 steps. I want you to pause the video and go ahead and complete the rest of the table and try the last column on your own, and then we'll review it once you're done. So go ahead and check over these answers, and we'll talk about the last row together. I had you try or attempt it on your own, and if you made any mistakes, then you can just change them as we go along. So notice, in every single one of the questions in this column, we always took a price. In this case, the price is X, and we multiplied it by 0.2, representing our 20%. So we would represent this by multiplying X times 0.2. When variables are involved, we don't typically write the variable first, we actually write it second, and so the number in front, which is known as the coefficient, goes first. So I'm going to rewrite this as 0.2x. The next thing we did was we subtracted the original price by our result from the first column, so this would be the original price is X, subtracting this column, which is 0.2x. Now, essentially what we were doing in our heads was we were subtracting these two. So I want to show you how they're actually getting this. So we have x minus 0.2x. Notice that what they have in common is an x. So we talked about how distributive property works, how we can multiply the number from the outside into both of the numbers on the inside of the parentheses. Well, we can also go the other way and take the common element out of two terms. So here, the common element between these two terms is x. So I'm going to take the x out in front. And what's left here, x divided by x gives us 1, minus 0.2x divided by x gives us 0.2. And so when we subtract these, 1 minus 0.2 gives us 0.8. And that's where we get the idea of multiplying 0.8 or 8/10 times x, which is the cost of our item. So notice that these are equivalent expressions. This problem here and this problem here are equivalent expressions. All right, let's take a look at example 3. An item that has an original price of X dollars is discounted 33%. Write an expression that represents the amount of the discount. So let's take what we learned from the last example. We know that to discount means we are going to take the whole price of the item, in this case X, and subtract it by 33% of the cost of the item. So 33%, we can take that, move the decimal over twice, giving us 0.33 of the cost of the item. We know of means to multiply, and the cost of the item in this case is X. So this expression tells us how to calculate the discount amount. Part B says write two equivalent expressions that represent the new discounted price. So as we talked about in the previous example, if they have a common element, we can factor that out or do the opposite of the distributive property. So when I do x divided by x, we're left with 1. Or you could think of it as x times 1 is x, and x times 0.33 gives us 0.33x. And this is a negative because a positive times a negative gives us a negative, so 0.33. For our second equivalent expression, we can simplify what's inside the parentheses here. 1 minus 0.33 gives us 0.67, and then just to throw in for good measure, another equivalent expression here would be 0.67x, because we're switching the order here using the commutative property. So here are actually 3 equivalent expressions that represent the new discounted price. Use one of your expressions to calculate the new discounted price if the original price was $56. So looking at these 4 different expressions, here, 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 and here, what do you think would be the easiest? Well, if there's less numbers to work with, it would probably be easiest to do this one. So I'm going to substitute x with $56. So when we multiply those two, we get $37.52. And notice that's a lot less work than having to take the cost of the item, multiply it by 0.33, and then subtract that from the original cost of the item. So it's much simpler if you can think ahead and think about what percentage you're actually paying for. If it's discounted 33%, we're paying 67%, because 100 minus 33 is 67. Part D says, how would the expression you created in parts A and B have to change if the item's price had increased by 33% instead of the discounted 33%? So in this case, we would take the cost of the item, and instead of it being discounted, it's increased. Another word for that is markup. So you might want to become familiar with that. A markup is an increase, so this tells us to add 33% of the cost of the item. So again, I'm going to turn 33% into a decimal, 0.33. Of means to multiply, and the cost of the item is x. So let's create an equivalent expression for this. We know that this is one whole, so what I can actually do here is combine like terms. So what we have here is 1 whole x plus 0.33x. Combining like terms gives me 1.33x. So this expression would be how to calculate any price that is increased by 33%. Take a look at the difference here. So in this case where the price was discounted, we're taking the 100% and subtracting 33% to leave us with 67%. In the markup case, you're really taking 100% of the item and adding on 33% to give you 133% that you're paying for the item, which is equivalent to 1.33.